Question 1. Who's reading?
I can read.
Okay, perfect.
Photoelectric effect. The work function of the tungsten surface is 5.4 eV. When the surface is illuminated by light of wavelength 175 nanometers, the maximum photoelectron energy is 1.7 eV. Find Planck's constant from these data.
Perfect. How do we do this? So remember that equation that we had in stars? That's what you're going to need. So there are two options. You can either convert electron volts into joules, or you can convert your Planck's constant into electron volts. However you want to do it. So I'm not telling you how to do it exactly, but let's start the equation. So kinetic energy max was what? HF minus HF0. Or kinetic energy max could also be written as HF minus phi, the work function. And we know F equals C over lambda. So now what all are given to us? We are given the work function for tungsten is 5.4 electron volts. We are given the wavelength that it is incident, 175 times 10 to the minus 9 meters, right, nanometers. And the maximum photon energy, kinetic energy, photoelectron energy is 1.7 electron volts. And we are being required to find Planck's constant. So it's your choice. You can either find the Planck's constant in electron volts or in joules, whatever you want. Do we all understand how to do that? Good. People on Zoom, make sense?
Yes.
Excellent. Next one. Who's reading?
The threshold wavelength for emission of electrons on a given metal surface is 380 nanometers. What will be the max kinetic energy of ejected electrons when lambda is changed to 240 nanometers?
Okay, again, what equation are we going to use? The same one that was in stars? Yeah, but in this case, what are we given? We are given lambda, let's say lambda 0 as 380 nanometers. And they're asking us in part A, what if lambda was changed to 240 nanometers? So we're going to use our same equation. We have to find lambda, kinetic energy maximum, which was HF minus HF0, or HC over lambda minus HC over lambda 0. Do we know H? Do we know C? Do we know lambda? Done. Yeah? People on Zoom, make sense? I would recommend in this case, let's find the answers in electron volts, just so we get used to it. So find the answer in joules and then convert them to electron volts. They just look prettier in electron volts. So instead of like getting an answer that's 10 to the power minus 19, blah, 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 which doesn't make any significant sense, I think the answer to this one is very close to 2 electron volts. It just looks prettier. Okay, part B. Who's reading part B?
What is the maximum electron speed?
Good. How do we find that? 1/2 mv squared. So we take the value we found here, plug it in here, make sure you have it in joules, or you can find the mass of an electron in MeV, either one. Does anyone remember the mass of an electron?
9.7.
Yep, so mass of an electron is like 9.1 times 10 to the 31 kilograms, or 0.511 MeV. So if you have your answer in electron volts up there for part A, then use MeV. If you have them in joules, then use the kilograms. Be very careful. Use the correct units. And you're looking for speed.
Mega electron volts.
MeV, yeah. Mega is 10 to the 6 minus, no, 10 to the 6. Okay, last one.
Loss of electrons due to the photoelectric effect will cause an isolated sphere of this metal to acquire a positive charge. Find the largest electron potential in volts that can be achieved by this sphere for the wavelength at 240 nanometers.
So electrons are leaving, so we will get a positive charge. Find the largest electric potential in volts that could be achieved by the sphere for lambda of 240. Aha. Okay, so we're going to use our same exact handy dandy equation, HF over 5. But this HF over 5, you're going to get from part A. I got very close to 2 electron volts. So what is kinetic energy maximum in terms of electron volts? About 2 electron volts. What is the charge of an electron? 1.6 times 10 to the minus 19 joules times volt equals 2 electron volts. And you probably want to convert electron volts into joules. So 1 electron volt is 1.6 times 10 to the minus 19. What? Yeah, that's okay.